Ready? Okay, so we're on our next sacred lab. It's the photosynthesis lab. We're going to go back and use our colorimeters. We're going to have to adjust the lab slightly because we're using the cuvettes instead of the big tubes. And you'll have 5 different cuvettes back there. And like we said before, each cuvette we're going to have to equal out in volume. And what we're going to be looking at is we're going to have to add the different amounts of chemicals of each. The big chemical we're looking at is the unboiled chloroplast. Chloroplast would have chlorophyll, which means it could do photosynthesis. What we're going to measure is the light reaction. In this case, our blank is going to be the one with the chlorophyll and the 2 drops of what we call buffer. And buffer we can talk about again, but you should know what a buffer is by now. The indicator for this lab is going to be the DPIP, which stands for something big and long, which you don't need to know, but it's an indicator. And what that means is when we add the indicator, this dark blue substance, to the chlorophyll, it's going to turn the chlorophyll, it's going to turn the DPIP clear. It's going to reduce DPIP, and it's going to become clear. We're going to use the colorimeter to measure the amount of light reaction that occurred. So if you'll follow me back here, we'll take a look. We need one of those rollers, Mr. Daddy, those movie rollers. And I gotta get the cuvettes. So this time through, what do I do with the cuvettes?
They're in that box over there.
Yeah, thank you. Anyway, this time through, we're gonna go percent transmittance, which is the opposite of percent absorption. And we're gonna put some chlorophyll, some unboiled chlorophyll, in the tubes. You can measure those out yourself. I'm just going to show you what we're talking about here. This chlorophyll is a little bit dark. We're going to dilute it more. And you know what I forgot is the water, but we'll assume there's water in there. I'm following the principles up there to follow those rules. We're going to make it a little bit diluted with the with the buffer. And then we need to add the DPIP. If you'll notice, the DPIP is a dark blue color. Right? So when that turns clear, it's been reduced. So we're going to get the light reaction to reduce the chlorophyll, and we're going to get it to become clear in the substance. I'm going to have to add water to this. So what are we going to need to do for the light reaction to occur? Well, as you imagine, we need light for the light reaction. So what we do is stick the cuvettes under the overhead. Right? It's going to be our artificial light. We'll have this set up so it's shining on there. And we're going to watch it go from dark blue to clear. Now, depending on the concentration of DPIP, it may take a while to go clear. So the DPIP, again, is going to be a dark blue. When it reacts with the chloroplast and light, we should see it become clear. Our machines this time are not going to measure percent absorption, but percent transmittance. So if we want a clear substance, if I want the blue to go back to chlorophyll color, green, we're going to tell the machine that green is 100% transmittance. When we stick this in the machine right now, it's very dark because of the DPIP. It should be reading a very low transmittance if all goes well. Again, we may have to play with that. We may have to play with those numbers during the experiment. The other thing that's gonna, oh, that's not what I wanted. The other thing that's gonna matter is the concentration of DPIP. So I know it says every 5 minutes in the lab. We may have to go down to just 1 minute in the lab. We're gonna be pushed for time. That's why we're doing this now. I appreciate you watching it because Friday's the assembly and we're gonna be short on schedule. And I am really not remembering what I'm doing here. Percent transmittance, there it is. And if we could press play, where's the play button on this? Oh, maybe I didn't do experiment yet. Anyway, we're gonna press play. Remember that the flat line has to go with the white line in the colorimeter. You're gonna put it in there. We'll have the machine set up already. You don't have to mess with those. And again, this number should read a very low number. It's the opposite of absorption. We're doing transmittance. So we're going to tell the machine, hey, tell us when it's green again. And we're going to say that's 100% transmittance.
What do you think?